It's important when you're considering topics as a first-time conference presenter to pick something that you're comfortable with. So, look, I've been in this industry about 10 years, but during that time I've spent, 5 years in a row in Python, similar chunks of time in C#, touches of C++, and frameworks come and go. Who has time to get expertise in any one like that? You need to pick something that you know as well as the back of your hand. And then 4 hours ago, you're sitting in there and seeing somebody put a bunch of slides that you could have included in your own talk. But I needed to pick something that I'm an expert at, and I've been programming since I was about this tall, which means more than anything else, I know how to write awful, unmaintainable code because I have been doing it for a very long time. So hi diddly ho coderinos, I'm Lachlan Kingsford and I'm here to share my expertise. But for the next 40 minutes or so, my evil counterpart, who I'm not normally allowed to let out at work, is going to be talking to you. Theoretically, we are here to learn from anti-examples, but when I look amongst you, you and I both know the truth. I don't know if this room that is more full than honestly I was expecting is a good or a bad sign for Melbourne's software community. If you're somebody who benefits from a transcript, so there is a QR code there, I'll leave it on the screen for just a couple more seconds. Mostly because I know I benefit from one. Okay, so before I go, into character, and just so I don't get in too much trouble when I put this laptop back on the work network later, I just want to advise that this is not actually how I am suggesting that you should write code. My employer isn't suggesting the same either. Okay, so how many Star Trek fans do I have in the audience? Great. Can you put on your imaginary mirror beard goatees? And let's go. If you take away one lesson today, this is it. If it was hard to write, it should be hard to read. We're going to explore this and dig into it a little bit. So, look, we're going to be interactive. This isn't going to work unless I get hands up. Who can tell me what the first hard problem in computer science is? Great, halting problem and hanging. Can anybody tell me the second, which is? Sorry? That's the third. But naming. So the third, I thought the third was off by one, but apparently it's how to avoid reiterating the pertinent points of a talk you saw in this room 4 hours ago. But that's not been covered today. Let's have a look at some example code. Now, I should quickly clarify, these examples, even where they look finance related, were written for the sake of this presentation. This is not actually how my employer has written code. Now, if we look at this example code, it is unfortunately maintainable. You might not understand immediately what it's doing, but let's have a look at what we've got here. There are meaningful variable names. We have a readable loop using the framework provided by the language. If what you are trying to do is write bad, unmaintainable code, this is obviously unacceptable. So, we've taken one step. We know as seasoned software engineers and developers that I, J, and K are the standard loop variables. So this is now more standards compliant. It is more stylistically correct and therefore it is better. But between you and me, I think we can do better again. Now, shorter code is obviously better code. If we compress this into a nested list comprehension, nobody's going to be able to read it, but it is shorter, so it must go faster. And good luck to whoever has to maintain that, because with any chance, you're in your next job and it won't be you. But creative naming can go so much further than the individual bits inside functions. If your function does exactly what its name says it is, somebody might accidentally understand it, and that is not what we are aiming for. As we're going to talk about later, if your format function has now grown to the point that it does something else as well, or even better, something else entirely, that's great. Now, classes, they're even better. Just because a class is called a generator does not mean it needs to generate something. This is a common misconception. And obviously, this will never get past code review, but the great thing is that it happens insidiously. You don't even have to tend to trying to write automatic, awful, unmaintainable code for it to happen. Classes and functions grow. That generator that was a generator 12 versions ago now happens to be doing 3 other things, including deleting a file. Better yet, don't even touch that doc string that was last accurate in 2016. We're trying to minimize the size of our code change here. Eventually, if you try really hard to not try really hard, your code will be awful and unmaintainable. Okay, so how many of you are CS grads? I know there's a bunch of you. You guys will have met Big O notation either formally at uni, and the rest of us probably met it at 9 a.m, American Eastern Standard Time, when we'd rather be asleep. Let's have a look at what is a reasonably efficient implementation of a toy arbitrage function. So it checks currency pairs for variations. So big O efficiency, who can tell me the efficiency of a Python dictionary / Java C++ map? Great, 01. So it's a constant time. Right now, if we look at this, we do have a loop, we've got a function, so it is an ON function, but we as a group, we can do so much better than this. If it was hard to think about, it should be slow to run. Now, here is something subtle. So instead of a dictionary, we're going to loop through a list. So every time we're going to check whether something exists, we're going to loop through that list, and quite easily we've turned an ON function into an ON squared function. Bigger numbers are better, right? But look at what we can do here in the interests of efficiency. So meet my friend, the double-nested loop. That ON squared that was an ON is now ON cubed, but it's carefully hidden in there, isn't it? So one of the things that Donald Knuth said was that premature optimization is at the root of all evil. And check out, I made an optimization if you spot it there. It would be inefficient to be appending more data to the list if it's already in the list, wouldn't it? But now, an extra loop, it's less efficient again. So I'm in finance. Most of you aren't. There's a calculator that is famous in finance. It's called the HP12C. It's a reverse Polish calculator that most of you will have never gone near. There's this rumor that the faster model they made was discontinued because people didn't trust it when it was returning too quickly. And you owe it to your customers and your consumers to trust your output. So we've been looking at code specifically. But what about the metadata around code? So most of you, I really hope, have used version control of some form. But what if I told you that instead of helping make your code maintainable, you can twist it too into your dark, inscrutable purposes? So this is a commit history. This is a very typical commit history, which I would expect to see from a high-performing developer. The comments suggest that those commits are small, they're focused. They've got commit messages that accurately state what they contain. You could use something like git bisect and Git blame really effectively with commit messages like this. You might, if you are truly uncommitted to the cause of awful unmaintainable code, be able to generate release notes from something like this. That's contrary to our needs. Here is a much better example of an unmaintainable repository. You see, if you start with something like this, and you rebase and you squash and you change the names, you run the risk of people understanding what you did and why you did it for years. When you're looking at a line of code in NeoVim, because it is the one true editor, and the blame shows workaround for issue 4 in library X versus progress and it's misspelt, which of these is going to help you maintain the code? Now, we're going to step out of the repository and see how we can optimize it for some proper awfulness. Control-C, Control-V. Just because we're in the LLM era, I'll be talking about it in a bit, doesn't mean that we've lost sight of this great tool for unmaintainability. Because the more places that your code exists, the more places it has to be maintained. So let's have a look at a unit test. I am sorry if you don't speak Python. I find it a decent teaching language because I think it's readable for most people. I'm hoping it is for you. But this poor, well-meaning developer who wrote this, I think it might have been me on a bad day, wrote a test that only defines logic once. If something about that logic changes, there is only one place that you need to update it. How tomorrow in stand-up, when you're giving a status update, because that's what we're supposed to do in stand-up, right? Can you hold your head high and your hand on your heart and say, I wrote 17 lines of code when you know deeply that you could have written so much more? What if, and stay with me here, instead you write it once, and then you copy and you paste it, and you make subtle but meaningful changes. The next lucky engineer has 5 opportunities to fix the same bug if they can spot what is different between them at all. But your juice is flowing because when it comes to copy pasting, I see so much opportunity for writing awful unmaintainable code. You can copy paste between files. Better yet, you can copy paste code between repositories. If you've ever thought, I think I've done something kind of like this before, copy it, paste it, comment out the now irrelevant lines of code that don't apply anymore. After all, they're not in that history, so you need them there. And how many of you work for companies of, let's say, more than 200 people? Cool. If you copy-paste that code into exemplars, you can spread your bad code over other teams too. Just think of the bliss that you will feel at 2 a.m. while you are fast asleep having fixed a bug, whilst another team is awake, having obviously not paid attention to the fact that you pushed a fix to their bug and didn't tell them about it. They should have been paying attention to the repository, right? That's their own fault. Now, it is 2026. I'm obviously not permitted to stand on a stage like this and not mention AI at least once. I have seen decent results at producing maintainable code with a few small guidelines. So, if you follow common practices, like you're limiting your pull requests to the relevant changes, if you minimize the size of the change, if you create unit tests from firm requirements, if you're paying close attention to what code is being written and actively look for pain points and areas to refactor, there is a good chance you might accidentally end up with good maintainable code. Heck, If you give your large language model strict instructions about the implementation that you're expecting, you might even get some modest efficiency gains. Why would we be talking about that in this room, huh? Now, as one of my favourite software engineers is about to quote, AI is the most exciting possibility in my lifetime for commoditising the ability of average and even above average developers to write awful unmaintainable code faster than they have ever been able to do so before. And I truly do believe this. AI can help engineers, regardless of experience level, enable them to write code that a junior who picked up a code editor for the first time last week wouldn't dream of writing, at a truly staggering rate that your team now has to review. So how do we go from good use of LLMs to what we're aiming for here? So we know if you write a 30-line pull request, every line of that gets carefully dissected. If you push 1,050 lines, LGTM, looks good to me. You want your changes large, the kind that most engineers will barely look at. Heck, even better, you want an LLM to look at that too. Developers are expensive. You don't want to waste their time on things like review. And you don't want to waste their time thinking up test cases, do you? I mean, you could say, this is the business function, test it. Or you could optimize your engineer's time by saying, I need 95% test coverage, go and run off and get a cup of coffee. So, as anybody who had the pleasure of being Serena's talk this morning saw, we can get AI to optimize for any metric we ask it to, even if it's the wrong question. And I'm suggesting, especially if it's the wrong question. And then we can both meet the metric, which was inevitably imposed by somebody up above, and produce nothing of value at the same time. And this, what I'm about to say, is relevant for the copy-pasters amongst you too. IBM, and I am hoping, if there's any IBM engineers in the audience can correct me, used to measure productivity by lines of code. You are now equipped with a tool that allows you to write thousands of lines of code while you're down the street. Why can't you measure your productivity in exactly the same way? Okay, I've gone too far. Good Lachlan actually needs to interject for a moment here. So when I look amongst this room, I'm largely seeing people who grew up watching The Simpsons at 6 o'clock on Channel 10. Do any of you remember that monkey's paw that you made a wish and it clicks and gives you in the weirdest and worst possible way? This is an old talk. I gave this 2 years ago internally at work. Since then, the whole LLM thing has happened. I have been advocating for test-driven development and behavioural-driven development and careful use of naming and keeping functions short for a really long time. And with LLMs, I might actually get it because this is terrifying. It actually makes them work better. So I'm sorry, apparently I made a Faustian bargain at some point in the past and we are all doomed. And whilst I am still being slightly, out of that character, I do feel like I need to interject with one other thing. We've so far looked through about 5 anti-patterns that I see pretty considerably. Some of you are hopefully going, this is pretty basic stuff. Except, so I've been working for about 10 years at a variety of companies. Every example you see is based on something that I have seen. Hands up if you have inherited code that has dealt with at least one of these things. Yeah. Hands up if you've written it. I don't believe the rest of you. And it's okay. These are things that lots of us do when we are new to the industry, when we're new at working on larger code bases. The hope is that we grow out of them, but the reason I'm talking to you is that I've seen these things from engineers who I would consider experienced enough that I shouldn't be seeing it from them. And what I'm hoping is that by talking to you in this way, I'm giving you some language and tools that you can bring back to your own teams and say, hey, maybe this isn't going to go so great in the long run, eh? Okay, I'm going to get that mirror goatee and put it firmly back on. I would have tried the real one, but I'm not sure how my wife would have felt about me shaving just the bits to turn it into a goatee. Let's talk about versioning. Now, we all know when you're in primary school dreaming of being a programmer, the thing that you really want is to make little version numbers go up. It is the coolest thing about being an engineer. Okay, for those of you who don't flirt with library design, semantic versioning is commonly regarded as good practice. Here's a quick overview of what it is. Major version, there's a breaking change. Something that your team used to be able to rely on previously doesn't work the same way anymore. Minor version, there's a new feature, bug has been fixed, etc. But it remains backwards compatible. A build number, which apparently is now called a patch version according to the latest version of semantic versioning, is a backwards compatible bug fix. So Python devs in the room, you probably use pip. Java devs, you guys use Maven. C++ devs, wait, is modules working in C++ properly yet? Now, most of those package managers treat semantic versioning properly, which means that if you increase the major version, you actually need to make an explicit decision that, hey, I'm going to upgrade this version. Why would you want that? If somebody is pip installing your library to upgrade it during an incident, why should they be able to count on your functionality continuing to work? Let me introduce you to versioning that I have witnessed a lot. Enigmatic versioning. Now, this one's going to hit a little close to home for a few of you, I am warning you. Major version. The product owner or the delivery lead needed a win this week. Minor version. The tech lead finally remembered to do it. Patch version, who cares? GitHub handled it. With enough discipline and the use of enigmatic versioning, your library can randomly break other people's systems. And if that library is public, congratulations, you have grown your blast radius beyond your own employer. That is true unmaintainability. So those breaking versions, you can make that major version increase a lot if you're one of those amateur teams using semantic versioning by making your procedures do a lot more than somebody might expect and then changing those extra bits frequently. So some of you, the less enlightened of you, might have toyed with a bit of functional programming in your toolbox. So pure functions are readable, they're predictable, they're readily testable, they're understandable. Now, another code example. Each of these functions does exactly one thing. And what's worse, it accurately states what it does. Now, I don't write in Java every day, but I got a Java friend to help me, and he told me my code was bad because my methods weren't in a class. So I put them in a class. And we've improved it. And you'll see now that format message helpfully stores the formatted value in the class too. So, you know, it's a bit more stateful, but we can do better. Now, our send function, if you look really closely, it modifies internal state. It formats a template that was passed in by reference, so it changes a different file too. It replaces a member with a different type. If you're in a dynamic language like Python, nothing is the limit. Every time you send that same template, which isn't even the thing that we're changing, the behavior is going to be subtly different. And these bugs, when you're trying to write awful, unmaintainable code, are fantastic. They are hard to detect. They are hard to reproduce. What's better is they are really hard to explain. Whoever is maintaining your code in a year's time is going to have to go through like 2 or 3 stand-ups saying, yeah, still working on that. But you can use your imagination, even if you're not in a dynamically typed language. You can close database transactions. You can close file handles. You can modify global state. You can change members in functions that look like they're just returning values. If you want to be really secretive about this, you can do it in properties too. So, my favourite author is, without a doubt, Terry Pratchett. I suspect there's a few other fans in the room. Woo! Great. So, B.S. Johnson, the disc's greatest and worst engineer, connected a bathroom to a pipe organ in what I'm going to call a surprisingly cleansing way. And a surprisingly cleansing way to the person who was in the bathroom. When we're thinking about side effects, what we are trying to do is what our quantum engineering friends might call spooky action at a distance. Because if it was hard to discover what it should do, it should be hard to discover where it does it. So everything we've focused on has still been quite small. It's still been quite on the micro level. But to create truly awful code, you need to think structurally. If I'm going to continue with my favourite ever side effect, because the best side effects happen completely accidentally. It's the kind of unmaintainability that can't be intentionally architected for. So, how many of you have money invested with Knight Financial? That's not surprising. They went bankrupt a number of years ago due to a feature flag mistake. So, if you want to Google a good article, search for PowerPeg, and you'll see just how much damage a feature flag can do. So, when you're building a programmatic trading platform, you might have some test code. That test code might, in a non-production environment, buy low and sell high, or it might buy high and sell low, as a feature flag might have enabled. That feature flag might be reused by another feature. Somebody may not have double-checked that all of the servers were running the latest version of the code. And your company might lose $440 million in the space of under 40 minutes. I want to drive home just how big of a bug this is. So, some of you are old enough that you'll be familiar with that time that NASA made some mistakes with one of the Mars rovers, with the imperial and metric systems, you know, it's complicated, and accidentally buried a rover on Mars. That cost $328 million. Somebody using a feature flag poorly, forgetting it was there, and then reusing it, cost a company more money than literally crashing a rocket into another planet. The takeaway is that when you build bad structures, you can make terrible, unmaintainable code. In this case, the structure of the program doesn't reveal its actual operation. Now, some of you like Java, and there are some great frameworks for doing this there. And most of you will be cloud native. So the structural fun applies there too. If your Lambda clearly does one thing, and somebody can understand it when they first read it, that's not helpful for it being unmaintainable. Could your Lambda instead, I wish I was making up this case, could it decrypt a file, re-upload it to a different place, trigger itself based on that upload, and then process it? And now it does multiple unrelated things. Perfect. And logs are another great opportunity. Why do structured logging that logs very targeted information when you can log everything and just have a bunch of grep queries? At 3 a.m, when prod has been down for an hour, you'll rock up, have your grep query, and you'll look like a hero being able to find exactly what you need, exactly when you need it. When we're thinking about structure, you could build one giant class that does everything. After all, we all know that global state is an anti-pattern, but having a singleton with some members that you change is fine. Or you could have 30 tiny classes, each with external and internal dependencies that need to be wired together in a very specific way and instantiated in a very specific order. And some of you Java devs must be beginning to wriggle in your seats a little bit right now. Either way is effective. What matters is that it is painful. So, how can you apply the lessons I've given you here today to your daily work? As you've no doubt heard, we're about fast delivery of features now. Craftsmanship is dead. It's for kernel developers who are stuck in 2023, not for those of us who are working real-world roles. If you faithfully follow what we've talked about today, you're not going to slow down your delivery speed. At the moment, your velocity metrics might even increase. Be prepared for a really bad pun, it's incoming, I was really proud of it. Software might be statically compiled, but it's not static. We add features, we update libraries, we fix bugs. So-called responsible teams treat it like a credit card that sometimes, right now, you need to buy something with some tech debt in order to get a feature out, and then they plan to pay that tech debt off. But there are two ways we can use a credit card. Instead, let's keep racking up more debt. In this case, debt is development time, and like credit card interest, it compounds. A feature that 1 year ago took 2 days might take a week. And let me bring this back home to you for those of you who hold the corporate credit card metaphorically. A small development team might realistically cost about $1 million. By pushing your team to always focus on immediate delivery over maintainability, you could be able to justify growing your team so it costs $1.5 or $2 million with no increase in delivery. And that's before we consider the $440 million production incidents. So what does embracing writing awful, unmaintainable code look like? You too can be woken up at 2 a.m. unable to understand what's going wrong. You can be responsible for new and novel ways to lose vast sums of money, end up on daily WTF, or better yet, the podcast Cautionary Tales. You can have stand-ups where you have been productive and sat down for 8 hours and achieved nothing. And your code base will, in time, be very hard to write, and it sure as hell will be very hard to read. So, if it's your thing, I swear I don't normally talk about bad code. You can follow me on LinkedIn or Mastodon, where I hang out most, or Blue Sky, but be warned on the latter two, I'm more likely to be talking about long board games about trains, music, and weird other things as I am software practice. But thank you so much for indulging me by being here. Thank you so much to the organisers for organising this event and giving me this opportunity. And you've got a little bit of time left to play bingo. Great.
Thank you very much for the excellent talk. We got a few minutes for questions, if anyone have any.
Have you ever considered the impact that code generation could have on your nefarious abilities?
It depends. Are you committing your generated code? So now when you talk about code generation, are you thinking LLMs or are you thinking the classic style of code generation? So I've seen those kind of templates be really effective for writing awful, unmaintainable code when the template is unclear and produces something that's unreadable, or when somebody makes the mistake of making a modification to the template, committing that, but then still regenerating over it with a series of manual steps. It can be twisted into some wonderful ways to write awful, unmaintainable code. Or you could use it the way it was designed and it will end up maintainably.
What do you think about helper functions? I have a very proud memories of a 500-line file of one-line helper functions I wrote in a university group project. How can you achieve awful, unmaintainable code with over-abstraction?
Ooh. That's a good question, because helper functions are already a pretty great way to make your code awful and unmaintainable. So there's a few ways. The difficulty of breaking up helper functions is often that there is a lot of state between the function that needs to be passed as you break it up. Pass it all. There's no need when you're breaking up that function to break it into clean little pieces. Pass the lot. I mean, your linter might tell you that that variable's unused, but it's going to be far more elegant.
Well, further on your ebook plan, what do you think of AI slop? How would you go about making it with free AI chat and ChatGPT it, and I don't know, your ebook plan on that?
Well, the great thing with, one of the best things about AI is it rarely pays attention to what it's done previously. So when you're using an AI over and over again on the same code base, lots of the time it's going to leave comments that were last accurate 12 versions ago. And lots of the time it will leave a function there that won't let you refactor, except it's no longer used whatsoever. So honestly, if you use a large language model and you're not paying attention, there's a good chance you'll end up with awful, unmaintainable code anyway.
What would you have in your perfect GitHub Copilot instructions file?
Ooh. In context or not? How about I actually go give a real genuine answer to this?
Both good Lachlan and bad Lachlan.
Okay. So, I would discourage it from renaming any variables that it doesn't actually expressly need to touch, even if they change. I would be encouraging it to make singletons and make large functions that do lots of things. Look, honestly, basically most of the things I've said here, the difficulty is that some people have gone to the effort of putting in security features into these things, which they might try to stop you doing something underhanded. So there are ways to be creative. For instance, maintain the styles that are used in the rest of the project, which if you've been studying these guides or you've been using LLMs without consideration, will help you a lot in the quest for writing awful code. Okay, more realistically. As a Python dev, I think PEP 8 is possibly a little strict, but I actually think it's a great guideline. One of the things I've done with juniors who I've noticed have had issues coming out of uni is to actually force them to strictly stick to that code standard. I think there are equivalents in other languages. At some point, it's like being a composer. When you're learning to write classical music, you go back and you learn to do the rules of writing fugues and four-part harmonies, even though that's not what you want to write, because it gives you this great basis for when am I going to break these rules. And at some point, those juniors who I were getting to stick strictly to PEP 8 compatibility actually will be able to spot the places that they can make it more clear. So one of the simplest ways that I would bring it back to something like that Gemini file is I would be asking it to stick very strictly to a code standard like that is extremely prescriptive on matters like functions doing one thing and the lengths of functions and the accuracy of names. Heck, most Python linters will actively reject your code if you call a variable I. Does that help?
I've got one last question.
Yeah, I've got another question for about Lachlan. So if you don't want to have to remember to add extra columns for potential future requests, would it be possible to add a larger data query to what you're bringing in, just in case?
It would not only be possible, it would be responsible. We're trying to minimize the size of those code changes, right? So why not get there ahead of time? But, okay, let's actually be a bit more discreet. Depending on what database you're using, if you're using something like Dynamo, here's something really scary, you might actually need to. Because some databases, changing them after the fact and after creation is actually really tough. And if you're using something like Postgres, you probably won't need to. Now, if we're going the bad Lachlan version, invert that. You want your Dynamo tables to be changing frequently in structure, and you want your structured Postgres databases to change never.
Before we wrap up, I'm just going to very quickly interject. I just want to very quickly acknowledge this session and the last session were both first-time speakers, which is insane. And this is also the biggest room that we have at DDD Melbourne. Can I just get a huge round of applause for your first talk ever?
Thank you so much.